Okay, I looked around YouTube and different things to try to find a good explanation of data modeling. Um, and this is the best thing I found, and it's not a video. It's at this site, Credera. Not quite sure what they do. Let's take a look. My guess is it has something to do with data. Now, let's just see before we go forward. They value us. Okay, well, I guess they have empathy then. That's good. Firm overview. Management consulting. Clients range. Strategy, organization, process analytics, user experience. Okay, overview of service areas. Let's take a look. Well, I guess they must be based in Colorado or something, given the visual they're giving us there. Okay, well, analytics and insights, cloud and infrastructure transformation. Okay, so there's your database work that they do. Okay, let's just go back to home if we can do that. Let's see if they're going to let us go back. Although actually what I wanted was the 10-minute explanation of okay, hang on everybody, just bear with me here. Okay, let's see if I can get off of this. And let me go back to the link. Okay. I just wanted to see a little bit more about them. All right, so I think you just go ahead and read this, right? So physical model is how data is physically stored. Data are physically stored. Data is plural. Datum is singular. In a database. So that's that gets to the how is the cloud set up? Where is the data storage? Conceptual model, user view of the data. Logical model, assists between physical and conceptual. It allows for the logical representation of data to be separate from its physical storage. So that talks about dashboards and things. So these are some of the entities that are in a typical database model. You got a product database, right? Just think of that: product ID, vendor ID, product name. There's some kind of UPC code. There's size, variance, color variance. Vendor ID, vendor name. So the people who sell the products, think about Amazon, right? And then customer database has some of that information. That's probably your parent database there. And then you've got to connect things, build the relationships. Relationships between entities can be one-to-one, one-to-many, or many-to-many. Relationship between products and vendors illustrates a one-to-many relationship. If vendor A makes widget 1 and widget 2, that means a single vendor makes many products. If you think about this relationship in the other direction, it still makes sense. I can purchase multiple products from the same vendor. One-to-many relationships, by far the most common type. It's important to know how to deal with other kinds of relationships. Okay, one-to-one usually occur when a business needs to use entities that are supertypes and subtypes, also called parents and children. For example, a product could be a supertype, and a specific kind of product, like a book, could be the subtype. Some situations are good reasons for storing general product data in a separate table for more specific data about books. So, interesting. So you'd have different tables, one for books in general, and the other with data about each book. Single book title should be associated with a single product ID number and vice versa, making this a one-to-one relationship between products and books. Okay, as you see here, and you know because you saw optional one, there's some symbols here, I guess, in terms of how you graphically illustrate this. Third kind of relationship is many to many. Happens when multiple instances of one entity are related to multiple instances of another entity. Books and authors are a great example. One author can write multiple books, and a single book can be written by multiple authors. Yeah, true. Okay. Books table, authors table, author book table to link the two. Interesting. Book ID, ISBN, that's each book's individual number that they have. Genre, right? Romance, mystery, science fiction. Authors got an author ID number, right? First name and last name. Author book, some kind of record ID. A book ID and an author ID is captured in author book. Interesting. Data modeling should enforce data integrity. We talk with clients, data integrity is crucial. You need to be able to trust the data sets are accurate and reliable. Entity integrity and referential integrity. Entity integrity means the data are reliable. They finally got it as a plural there. Use of primary keys. Primary keys are unique identifiers such as product ID numbers that serve the purpose of identifying a particular record and preventing data duplication. So you're deduping even your product databases, right? All entities have a primary key, like the customer ID number, product ID number. The value of all primary keys must be unique. The value of a primary key cannot be nothing. Okay. Relationship between two entities or tables is reliable. Referential integrity. Use of foreign keys is an essential step towards referential integrity. Foreign keys are the primary keys of one table that appear in a different table. The rule of referential integrity says that for any foreign key value in one table, there must be matching primary key value in the reference table. Data modeling involves normalization, process by which anomalies are avoided and redundancy is eliminated. The concept was first suggested by a data scientist named Edgar Codd. Well, this is getting fancy. Well, here's an example. I want to store data about customer purchases. I want to know information like the dollar amount, purchase, the customer name, and the store where the purchase took place. If it's stored all in a single table, that will lead to problems. For example, a customer who's made hundreds of purchases may get married and change her name. To reflect that change in my records, I would have to go through my table and change her name for every single purchase she's ever made. Well, that's a really good example of why we have a relational database, not a flat Excel table. One database for everything. Make only one change for her, and that rather than having to change every record of every product. Okay. All right. So, okay, we have that. Different models have different purposes. Important to have discussions about the purpose of the data model. Two types of data models, relational models and dimensional models. They serve very different purposes. So dimensional data modeling can result in a design called a scar schema, which is denormalized tables can be used for building, reporting, and analytical systems. Dimensional models are designed to be great at getting data out of a data warehouse into the hands of business users. Make it much easier to query across many different tables. Okay, well, star schema and relational. Interesting. Data modeling matters. Moving forward with data modeling. Well, good. Some nice explanation of data modeling and recalls a lot of what we did with Access, and I hope you guys agree.